This is a lecture on Chapter 7.3, Simple Radical Expressions. Please refer to the notes in the handout. Our objectives for this chapter is to know how to multiply simple radical expressions, and our second objective is to know how to take factors out of a radicand. So today we're going to discuss the difference between an index and a radicand. We just want to remind you that this is the radical symbol. The index, in this case, would be 3. That's the index. And the radicand is any number or variable that's under the radical symbol. So to multiply radicals, expressions, we have the following idea. Let A and B represent real numbers such that the radical symbol n, index n of A, and radical symbol of A or B, index n, are both real. So I can multiply the two radical symbols here. These two radical symbols can be multiplied together, and they can be put under the same radical if they have the same index. So, for example, if I had the square root of 5 times the square root of 75, I could then have this the square root of 5 times 75, right? Which is equal to the square root of 375. Well, in some cases, what we could do is we can, since our index in this case is 2, we can put everything under the radical symbol in terms of the squared of the index. So this is 5 times 25 times 3. I can pull out a 5 out of here, and I get what's left over, 5 times 3, and I have a 5 out here in front. This is just 5 square root of 15. So that's the answer. For the multiplication property, works both ways. So the square root of, in this case, of 144 is equal to the square root of 4 times 36. Notice we put these in squared terms because the index is the square root, right? So now this equals the square root of 4 times the square root of 36, which is 2 times 6, which is 12. So the square root of 144 is 12. That makes sense because that's what we do in our number tables. So the rules for simplifying radical forms are the following. Consider any radical expression where the radicand is written as a product of prime factors. The expression is in simplified form if all of the following conditions are met. 1. The radicand has no factor raised to a power greater than or equal to the index. The radicand does not contain a fraction. 3. There are no radicals in the denominator of a fraction. So in the following example, we want to simplify the expression assuming that x is greater than or equal to 0. So in this case, we have the fifth index, right, the fifth root of x to the 8th power. So in this case, we see that, in fact, right? We have the fifth of x to the eighth, and we can write it this way. I will write it this way. The fifth power, x to the fifth, times the fifth power of x to the third. Notice here I've broken out 8 into the two pieces of the radical, and I can do that using the rules of radicals. So now I know this one just becomes x, and I'm left with the fifth root of x cubed. So in your notes you will have more problems than what I'm showing here, but we're going to first simplify the expressions, and we assume that all the variables are non-negative real numbers. So in the first case, I have the cube root of 32x to the fourth. Now again, I can change this to the cube root of 2 to the fifth power times the cube root of x to the fourth. And you can see now this just becomes, I can take a 2 out, right? And I'm left with 2 squared, right? Cube root. And then here I have the cube root of x, and I've taken out an x, right? Times x, right? So to combine all this together, I get 2x cube root of 4x. So that's my answer to this particular problem. Now, the next problem that I'm going to do, I'm going to go down first to the square root of 64x squared, right? And I'm going to write this as the following: the square root of 8 squared times x squared y. Now you can see I can take an 8 and an x out, and I'm just left with the square root of y. So this just becomes 8x square root of y. Now I will do the problem here where I have the cube root, a negative cube root of 108 x to the sixth divided by 125. Now here's how we deal with fractions, and we have a radicand that's over both the fractions. I will put the negative up on top, so I'll have the negative cube root of 108 x to the sixth over the cube root 5 cubed of 3. You'll notice immediately the bottom one just becomes 5, but now the top I have, in this particular case, I think I have 27 times 4, so I have the negative cube root of 27 times 4 times x to the sixth. Hopefully you can see that. And so when I take the cube root, 27 is 3 cubed, so I can take that out. So I can take out a negative, there's a negative 3 here. Now, x to the sixth, that's just going to be x squared, right? And I'm left with 4. And on the bottom I have a 5 here. So there's my answer to that particular problem. The last problem, again, I'm going to change it to a fraction. So I have 4 on the top, and then I have the 4th root of x raised to the 16th power, and y to the 9th power, and z. And then on the bottom, I can take the 4th root of 6 and I just get 2. Right? So now I can start pulling out factors out of the radicand. The 4 and the 2 cancels, so I'm just left with 2 on top. But now if I divide the 4 into the 16, I get 4, so I can take an x to the 4th out. 4 goes into 9. I'll have 4 goes into 9 2 times, so I'll have y squared. But I'm left with a y underneath and a z. So I have a y and a z left. And then I don't have the 2 anymore because I canceled the 2 out. So there's my answer for this particular problem. So again, we're going to simplify radicals by using the order of operations. And in this particular case, we have a fraction. Our first example is 8 square root of 18 over 3. And again, we have the 8 outside the radicand, the radical symbol, and we see that 3 times 3 times 2 is 18, but I can pull a 3 out of the radical symbol, and I get 8 times 3, but 3 goes into 3, and they cancel, and so I'm just left with 8 square root of 2. So that's how we're going to do most of these. We'll do some sort of order of operation. So the first problem I'm going to work actually is going to be the one over here on the side, the 4th root of 256 x to the 8th divided by y raised to the 24 z to the 4th. Now again, what I'm going to do is I'm going to separate the numerator and the denominator out. And at the same time, I know I have 16, so this is 4 raised to the 4th power, and then this is x to the 8th, right? And then on the bottom, this is the 4th root of y to the 24th, z to the 4th. So this is kind of simple once I put it in this format. I can take out a 4, so a 4 definitely goes out. So I have 4 goes out on the top, and then I take 4 goes into 8 2 times, so that means I have x squared on the top. On the bottom I have a y, but 4 goes into 24 6 times, so I have y to the 6th. And then 4 goes into z to the 4th 1 time. So 4 goes into 4 1 time, so I'm left with z. So there's my answer to this particular problem. In the next problem, I'm going to move over here to 3 multiplied by a fraction of the 4th root of 16 x to the 5th y to the 8th divided by 2x. So in this particular problem, again, I'm going to put things into some sort of factored form. So 3 stays on the outside. I have the 4th root of 2 to the 4th, because I always want to put it in the index form if I can possibly do that. 5th y to the 8th over 2x. So now if I pull out a 2, the 2's will ultimately cancel, and I have an x that also cancels. So we'll show you how that works out. So I have 3 times 2x, and I'm left with an x underneath. Oh, and I also have a y squared here. So I'm left with an x here, and then I have a 2x on the bottom. The 2x's cancel, and I'm just left with 3y squared square root of x, and that's it. In the next problem, next to that, I have b over a squared times the 5th root of a22 over b25. Well, I'm going to leave the b a squared alone temporarily, and I'm just going to deal with the radical symbol. So I have the 5th root of a22 over the 5th root of b25, right? So this is just going to be b over a squared times, now 5 goes into 22 4 times, and I'm left with a squared term there. So I have a to the 4th, the 5th root of a squared, divided by, on the bottom, 5 goes into 25 5 times, so I just have b to the 5th. And now I have some cancellations to do. I have an a squared goes into a to the 4th a squared times, so I have a squared b on top square root of a squared, or 5th root, the 5th root, I'm sorry, there has to be a 5th root here, of a squared. And then a b goes in here, b to the 4th power. Right? So the b's, I'm sorry, the b's cancel. This b is not there. I'm sorry. So this is the answer that we get for this particular problem. So in our last two problems, we're determining the length of the third side of a right triangle. Write the answer in a simplified radical. So we remember the Pythagorean theorem. A squared plus b squared is equal to c squared, where c is the hypotenuse, a is the shorter side, and b is the longer side. So in this particular problem, we have the shorter side, 6 squared plus 12 squared is equal to c squared. And we want to find c. So we have 36 plus 144 is equal to c squared. In this particular case, we have c squared is equal to 180. And now when we take the square root of both sides, the negative square root doesn't work because it's a length. So we're left with c is equal to the square root of 180. And we know that 180 is 9 times 4 times 5. So c is equal to the square root of 9 times 4 times 5. Right? So we can pull out a 3 and a 2, which is 6. So c is equal to the 6 square root of 5. So that's our answer for the very top one there. You notice that here in this particular case, c is now 25. The short one, a, this is a, this is equal to c, and now we're looking for b. So in this case we have 25 squared is equal to 7 squared plus b squared. So we're trying to find b, so I get 25 squared in this particular case is 625 is equal to 49 plus b. When I subtract 49 from 625, I get 576 is equal to b squared. And it turns out that the square root of 576 equals b, right? But we know that the square root of 576 is 24, so in this case b is just equal to 24 centimeters. So that's the answer. So in this chapter we have tried to work with radicals and to simplify them. Please work on your homework for 7.3 and see if you can do some of the problems in the Math Connect.